Right. How are we doing today? All good? Thanks for being here. Normally I say thanks for taking the time out of your busy schedule to select me over other talks, but it's a single track conference, so still thanks for selecting me over having drinks or doing the hallway track. Now before I can actually start doing my presentation, I have a couple of statements I need to run by you to make sure we're on the same page, because if we're not on the same page, this presentation is going to fall apart. So there's several ways I'm going to do this. I'm going to give you a couple of statements, three to be precise, and there's some interaction required. You could, if you agree with my statements, you could nod, you could raise your hand, you can wave, you can jump, shout, scream. It doesn't really matter. I just need to make sure that we're on the same page. All right? Ready? If you're a bit more of the introverted type, it doesn't really matter. Like, you don't need to participate. Ready? Sure? All right, here we go. Slow websites suck. All right, great. This is also a trick I apply. This is one of my many party tricks that I check if we have a good audience. And we have a good audience. So, do we also agree that web performance rather, is an essential part of the user experience? Do we agree on that? Good. 2 out of 3. Last one. Do we agree that a website that is slow is just as bad as a website that is completely down? Somewhat. Yeah, more or less. Because when this happens, you lose money, you lose face, might even lose a little bit of Google PageRank on that. Now, a lot of people try to remedy for that by saying, okay, we have a capacity problem, let's just throw servers at the problem. That's one of the common ways of doing this, but in reality, it's not really sustainable. Now, on a short-term basis, when the house is on fire, you need to do firefighting, this is an excellent solution. But either you buy infrastructure, which is a capital expenditure, or you rent it, so it's a recurring cost. On the long term, as Biggie once said it, more money, more servers, more problems, right? Yeah, absolutely. Like, not my words, his words. Now, any sane person would do this, would identify the slowest parts and try to optimize it, either by doing infrastructure tuning, throwing out old stuff, putting new stuff in, or in terms of development, that would be either refactoring or throwing away the code and replacing it with new ones. And that makes perfect sense. Like, every sane person would do that. But the problem is, like, if you do that at scale, and if you have lots of improvements to do, you'll hit the limits of what you can do with refactoring, with tuning. You'll reach the point, as they call it, of diminishing returns, meaning that the amount of money and time you throw in doesn't give you the result you want. Now, the entire gist of this presentation hinges on the fact that caching could solve that. That's the idea of the presentation, and that's how we're gonna kick it off for the next couple of minutes. That being said, hi, my name is Thijs. Thank you for being here with me, and thank you for being in this baller ballroom, in fact. It's great, and I'm very grateful for being here. I would like to commend the organization on hosting this one. Like, if this is the way they run their first event, fast forward 3 years, I don't know what can happen. So, yes, that was what I was aiming for. I'm a technical evangelist at a company called Varnish Software. And now, by show of hands, who has heard of Varnish Software before? That's quite good. That was a lot better than I was expecting. Usually I use the very diplomatic sentence, there is room for potential. But I don't have to use that here. Thank you for recognizing this fact. Now, for those who don't know us, we're the company behind the very popular open source project Varnish Cache, which is a HTTP accelerator. And for those of you who are still a little bit confused about that, we checked with certain tools, and apparently 4.8 million websites use our technology. And that's the ones we could measure. There's plenty of those that we can't measure. And if you look at the top 10,000 busiest and biggest websites, between, I would say, 19% uses our technology, give or take. Now, this is not the only thing we do, of course. We also offer enterprise software. This is the way we make money, and part of that money goes back to the community. Because a lot of my colleagues who develop Varnish Enterprise are also the core contributors behind the project we like and love. That's basically how it works. I'm also available on social media. This is an excellent way of getting in touch with me later, or getting in touch with me right now. Heckling, I don't mind. If you are that kind of person, I'm willing to accept that. Now, I'm also the author of Getting Started with Varnish Cache. It's an O'Reilly book about the subject. And luckily, I have a free copy of the book that we're going to raffle. Freek is going to do it. I'm not going to be bothered with that. Freek is going to find an excellent way of anyone who is interested giving that one copy. But let's get back to the subject at hand. Varnish Cache is a reverse caching proxy. And under normal circumstances, this is the interaction level you'll have. A user will be under the assumption that there is a direct connection with the server. Now, if you have lots of users, this can cause bottlenecks. The way Varnish and any other reverse caching proxy, or even CDNs operate this, they just stand in the middle and just protect the server from excessive load. It does this by taking the request, looking the response for that request up in cache, And if it's there, it will serve it without having to serve anything from the origin server. And if it's not there, it will make a single backend connection, fetch the data, and remember it for later purposes. And under usual circumstances, both the user and the server aren't always aware that there is this thing in the middle. Right? Sure? No. Yes, no. I anticipated for that. It might sound confusing. And I've done this many times before, and yes, this is yet another one of my party tricks. I always throw in this one. And I think a couple of people already seen this slide, but I'd like to stress that it is very important to take away the confusion. What do we see here? Who has seen this movie? What movie is this? What 90s blockbuster are we talking about here? The Bodyguard, indeed. And this is the metaphor that we're going to use. This is Kevin Costner, and this is the late Whitney Houston. This is your backend application. This is Varnish. All right? Okay? We got rid of that confusion. Let's carry on. Now, it's all about HTTP in the wonderful world of Varnish. And I shouldn't necessarily say Varnish like every other reverse caching proxy or CDN solution. And all of them can respect the HTTP best practices. And the cool thing is that HTTP has plenty of vocabulary in there, plenty of semantics that allow you to tune your cache accordingly as a developer. This is a very concrete example of developer empowerment. I think who's the developer here? Most of us are, yeah, of course. For developers, this is a way to instruct the cache to behave in a specific way. You can use different variants here. I'm not going to go into too much detail of how you can control the cache, how you can create cache variations. But the problem you have in reality, in the real world, is that state often interferes. And state is a difficult one. And with state, I mean user-specific data, personalized data. And those can come under the form of authentication headers or cookies. Now, under both circumstances, it's a bit problematic. Because if there are either authentication headers or cookies, and with cookies I mean either a cookie that is stored in your browser and that is transmitted upon every request, or also set cookie headers that you, in your application, set change the state. It's all about either keeping track of state or changing state. Now, in either way, this is not really cacheable. This is for your eyes only content. And I've made that mistake when I first started discovering what Varnish could do. You just make it as good as possible, you try to cache everything, and all of a sudden you have this login field that says, welcome, Thijs, and it caches it, and then Bram and Tom and Thomas and whoever's staying are just going to go to that website and going to see, welcome, Thijs, and that's a problem. Because that stuff is for your eyes only, the default behavior of Varnish is not to cache. So, in short form, whenever Varnish sees a cookie, it won't cache. So, what are we doing with this, right? Because who uses cookies on their website? There's people who didn't raise their hand. Are you using Google Analytics? Then you're using cookies. It's just not you that's setting the cookies. So in fact, I would say that Varnish is not applicable to any application in the world because nearly every application has cookies. We all remember the annoying bar you have to click on the bottom, you have cookies. Luckily, there's this thing called the Varnish configuration language. That's a DSL, a domain-specific language. It's actually a programming language within Varnish that you can hook into the different elements and start tuning the behavior accordingly. And I have a little bit of an example. Don't be scared if you're not a VCL, if you're not too common with VCL. So what we're doing here is we're hooking into VCL receive, which is a state. We have a finite state machine. We're hooking into the part where requests comes in. So you receive a request from your browser, and the first thing we do is we check if there is a cookie that was set. And then we use this horrendous regular expressions that you can see here. It scares the hell out of most of us, including myself. But the gist of it is that we try to remove every single cookie except the patterns in red. Now, anyone knows what CMS I stole this from? What CMS this reflects on? This is Drupal. This is a VCL file, a piece of VCL for Drupal, where Drupal has sessions identified by ses and then a hash, or sses and a hash. And Drupal sometimes also issues no cache cookie. So whenever we see those, we'll leave them. Everything else is removed by this regular expression. And in the end, if it turns out that we have nothing left after the substitution, that means there was no session cookie, we just have an empty string, we remove the cookie. If it turns out we did have a cookie, and it would be either of those red ones, we pause, and pause means we don't cache. So all of a sudden you create this situation where whenever someone is logged in, and on most websites that will be the admin, you don't cache. If someone else is there, the regular user, you do cache. So all of a sudden you create this flexibility where something wasn't cacheable due to personalization reasons, all of a sudden it is cacheable. And I'm sorry if I have to say that, that I'm painting cookies as something evil or bad, but that's not really the case. Because you can embrace cookies if you want to. This is an example. I wish I added the print screen, but I only have 30 minutes. I go into much more detail. Imagine that you have a website where you have to do language selection based on a splash page. First time you go to the page, you get a language selection drop-down list, you select the language. And once that's done, the cookie, the language cookie, stores the language you have selected. And then the idea is that the next time you go to the website, any page, you get the content in the right language. But the problem is if you add caching to that, it will cache the splash page. And every next user will see that splash page, and that's not the intention. So what I'm doing here is I am extracting all the cookies except the language cookie. The language cookie can stay there. But what is funny about this is I'm just putting the things upside down here. If there aren't any cookies, we're not going to cache. And if there are cookies, we are going to cache. We're going to throw the world upside down. Why is that? Because imagine that you don't have the cookie yet. That means you still need to select your language. You have to go there, select it, click it, cookie will be set. So in those circumstances, we won't cache. But as soon as the language was set, we are going to cache, and we're going to do more. We're going to extend the way the caching behaves. Because normally in the cache, you have a URL and a host name, and that will identify something in cache. That's your unique identifier. What I'm doing here is I'm adding a piece. I'm extracting here from this group, I'm extracting the selected language, and I'm adding it to the hash, which means I can cache different variations of my page. The Dutch version, the English version, the French version. And all of a sudden, we're embracing cookies and we're embracing personalization. Okay, we have an impact on the hit rate, but it's better than nothing. Now here's a simpler way of doing all this using a module, a Varnish module called vmod cookie. You keep the language, you write it back to the cookie, and then you extend the hash, get the cookie, and get it done. Right? Still on board? Let's take it to the next level. Let's apply this in practice. Imagine that you have this typical construction of your website with a header, navigation, a footer, and a main page, but you know that the username or the number of shopping cart items are there. What does that mean if in practice? You can't really cache it. Because it's not a specific part of the website that can't be cached. The state is everywhere, so there's no way of caching. So you put a varnish in front of it, it won't work. Luckily, I'm not a guy who presents problems. I try to present solutions, and the solution is placeholder technology. And there's common ways of doing this, and I think most of you will be familiar with that, where you take this header away and turn it into a separate HTTP request and put a placeholder where that will be replaced. Any idea of techniques we could use that are known to you? How do you solve this problem? Can you rephrase that? Because, whoa, that was interesting, because I've done this presentation many, many times. And I've never heard the word server-side includes. Because I even have a joke included about server-side includes where I would check the age of the crowd based on the fact, like, who has heard of server-side includes before? I'm going completely off the cuff. Like, most of you haven't. We'll save that for within a minute. But, like, it's a good idea. But any other ideas? How would you create a placeholder and replace this with something non-cacheable? Come on, guys. Yes. Yeah, well, I'm not really familiar with the front-end layer. I'm just going to call it AJAX, right? But you get the idea that you do a separate request, and there's pros and cons to it. It's a client-side thing where JavaScript will make an HTTP call, and Varnish will then make sure that it's not cached, and the rest of the page is cached. So, in fact, most of the page, like 90% of your page will be cached, and then like 10% won't. And the cool thing about AJAX or web components or whatever you're using is it is at the browser level, so it uses JavaScript, so it's common knowledge. Most people know it. And you can load it in parallel. And there's this sense of graceful degradation. And with that I mean, if something fails, you just don't load it. Your page doesn't blow up. It's like that component, that widget there. It doesn't work. Okay, you don't load it, but the rest of the page is visible. But there's also clear downsides to using AJAX or web component or JavaScript-based round-trip calls. And as I indicated, it's a round trip. It's extra round trips. So all of a sudden, you're shoving all that responsibility, which is mostly logic-based, you're shoving it off, pushing it to the browser, and the browser has to deal with that. Those are extra round trips, and extra round trips cause latency. Especially when you're a really crappy 3G connection somewhere, that extra round trip will matter. That's why there is a thing like edge-side includes, which resembles a lot like, and the joke's completely messed up now, thank you very much, like server-side includes. I'm not gonna ask you to raise your hand who knows server-side includes. Like who's old enough remembers it's just a tag that looks a little bit like this. These are ESI tags, but with SSI. And server-side includes, that's actually pre-PHP. It was actually a way of including files. It was actually Apache, so you could write plain HTML, write tags that looked a little bit like this, and then you could execute Perl scripts or virtually load files. You could even print the date. That was very, very old school. But edge side includes does the same thing. It drops a sort of marker there, a placeholder, that can be interpreted. Not at the server side, as ESI would indicate, but at the edge side. It's a very fancy word, edge. Edge means the outer tier of your platform. Mostly that's either your Varnish, another reverse caching proxy, or your CDN. That's where the world gets in touch with your application. Sort of the protection layer, the origin. So what this does is you could drop this in your application and then have Varnish interpret it, parse the header to a sub request, and fetch it, and apply proper TTLs to it, and respect the state, respect cache control header. So, in fact, and that's the cool thing about it, for all these bits and pieces that can be loaded as sub request, state and TTL is respected, but the output is a sort of composition of all the blocks. So as an end user, it is all processed server side. You see this page coming in, and you have no clue that parts of it are cacheable and parts of it aren't cacheable. That's an excellent way of doing this server side. And here's even a way written in VCL to do this automatically. Are there any PHP developers in the room? Just because I come from the world, I have to admit, like, I am Thijs and I come from the world of PHP. I apologize, but I don't apologize. And this is a way that Symfony does it. Because the Symfony framework has a sort of quick bridge in it that allows you to render ESI using a render function. And behind the scenes, it does two-step handshaking. Whereas it's up to Varnish and the first line in red to issue a statement that it supports ESI, and it does so by using surrogate headers, in this case, surrogate capability. And then on the way back, it's up to Varnish, or to your application rather, to spot that header, and to know, okay, I'm sitting behind an ESI supported Varnish. So the next thing it does is it starts emitting ESI, but it confirms by issuing a surrogate control header that whatever you're seeing here requires ESI process. You all can read if statements, I hope. You will see that we give this instruction to Varnish, and Varnish will then read these ESI tags, these, processes it, get the header, store it separately, and you're done. Good thing is it's server side, it's processed on the edge, it's very, very fast. But it's not that common. Like, who's used this technique before? A couple of brave souls, 3, 4 people out of 250, so we could conclude statistically that this is not common knowledge. Problem also is that in the open source version, it's a sequential thing. So if you have 4 different placeholders to load, you have to wait until the first one, second one, third one. And if one is slow, all is slow. And there's no graceful degradation whatsoever. So if one blows up, it just boils up, bubbles up to the top, and Varnish will return 503 backend not available. And you're done. It's a bit problematic in that respect, but yet a lot more powerful than web components or AJAX. Regardless of the one you choose, doesn't really matter. You'll use placeholders either way. You still have an attack vector, as we call it. You're still very prone to attacks because I'm not talking malicious attacks. I'm talking actual load being dropped on your system. Well, 90% of it will be handled, but then you'll have that remaining 10% that is by nature very compute intensive because it requires certain computations, it requires database access, it requires API access probably. So those are the most vulnerable parts of your application. Again, not in terms of security, but more in terms of stability. Luckily, again, we don't focus on the problems, we mention them, we try to find solutions. And one of the solutions is, and that's the cool thing, Varnish is not just a cache. Or at least, and I've written it in small print, not a take it or leave it cache. It's not like most examples that you've seen is, okay, we can cache this page because there's no cookies, or we can't cache this page because there's cookies and we actually need them. There's another way around it. And one of our clients eloquently said that Varnish is more than a cache, it's also an HTTP logic box. It's a nice way of putting it. I was very intrigued by that. What it basically means is that if you consider as an origin shield that protects your backend application by implying or implementing caching, we can also make decisions at the edge. So all of these authentication decisions or session state decisions, instead of making them in the application and then requiring placeholders to deal with them, you can actually do that in Varnish. And I have some rather advanced VCL code to show you. You see the title, Synthetic HTTP. Synthetic means that whatever you're outputting, the source didn't come from this regular backend interaction. We're figuring it out ourselves. We're faking the fact that we have a backend. So what you see here is that we're including a bunch of modules, but the main one that you need to remember is the Redis one. Out in the open, you can compile it, it's up on GitHub, and we open a connection to Redis. And in this example, where you won't really see the end result, rather the VCL because of time constraints, is I've built a Symfony application, a proof of concept, where you use typical Symfony logic to do authentication, and then Symfony behind the scenes stores username information in its native session store. Now, in this case, I've configured the adapter to be stored in Redis. So what I'm going to do here in this example is I'm going to get the username in Varnish so that you don't need to worry about that. We can do it, and we're fast. We can easily process 100 gigabits per second per server encrypted. No problem whatsoever. And that's just the marketing number. In our labs, we've easily processed over 150 gigabits per second. It's a lot of data. We're known for our stability. If you could do that at the edge side, there's no problem in interacting with that. And then again, Redis is also super fast. No problem whatsoever. Okay, back to the code. I think you're anxious to read some code. So what's going to happen here is Varnish also, unfortunately, has no notion of variables. So a trick we apply is we inject custom headers to transport information. In here, we're setting the request header x login. It doesn't really exist. It's a way of transporting or defining if we're logged in or not. And the basic assumption is no one is logged in unless proven otherwise. We also fetch the PHP session ID, which identifies our session in the cache, and we store it in a variable called, or request header called x session. That's our session ID. If there is no session ID, the fallback will be guest. So you're logged in as a guest. If it turns out you're not logged in as a guest, we're assuming you have this hash. Instead of just making this assumption, we're actually going to do an exists call on Redis, and we're going to, like Symfony framework has this prefix, sf_s, we're going to paste the session ID that we have, we're going to execute it, and if the integer reply is 1, that means it exists. And if it exists, we set x login is true. So not only do we assume if someone has a hash that they're logged in, we're actually checking it in Redis. And again, Redis is super fast. It scales well. There's no issue whatsoever. Now, when you then start, we'll have an endpoint called session, and session is just like an API call that will return my username in JSON format. And when that is not stored in cache, we're hooking into backend fetch, and backend fetch is part of the state machine that before you connect to your origin server to get the actual data you want to return, you can manipulate it. And that's exactly what we're doing, because again, this example is a synthetic example. We're not actually going to talk to a backend, to an HTTP backend. You see here that if the backend request URL, if the URL we're trying to connect to at the backend level, equals session, that means in some way, shape, or form, JSON should be returned, including the username. If it turns out that we're not logged in and we're trying to access it, I am just going to return an empty JSON object. You're not allowed to see the username. You don't really have a username. And instead of serving that directly, because Varnish has ways of delivering it directly to the end user, I'm going to use another module called synthetic backends. And synthetic backends, as the name indicates, is a fake backend type. It tricks Varnish into believing that whatever you're getting back as a string effectively came from the backend. But it didn't. We just invented it here. I'm just injecting an empty string, and that will be stored internally in Varnish. And that makes sure upon every subsequent request that we don't have to connect to Redis again to check this. We just have it in cache, which makes it lightning. If it turns out that you were logged in, we're going to do an eval statement. Yes, eval is just as evil as in any other language. It will issue scripts. And what kind of scripts are we executing? Well, Redis supports Lua. So I'm going to transport a little bit of Lua magic here, where I'm going to get a key that we can inject here. This is the value of this. And we're going to get that key in the session store. And then I'm going to do some magic here and substitute ugly characters that aren't liked. And everyone knows what PHP serialized data looks like. It's ugly, right? It's really ugly. Well, ugly data sets require ugly regular expressions to get it. So I'm doing all this kind of mumbo jumbo to actually get the username. And either we return empty objects, but if in the end all conditions are met and the stars align, we can end up synthetically returning the username. And then again, we'll be fetching that and storing that in synthetic backend. Upon every subsequent request, the actual username that's supposed to be sent by the backend, but that's way too compute intensive, this one is going to handle it quite efficiently. And to add more trickery, we're going to set the content type right. That's at the backend response level, assuming that the backend responds back. But it's a fake backend, so we could do it here. We're going to cache it for an hour, and we're going to create a variation, because if before that endpoint just store the username there, we're back to square one, where we just cache stateful data generally. It's for your eyes only. So we create a variation, What variation? Based on X session. Now, X session, again, if you remember correctly, we've set that here. That was that value. So that means for session, if you have the cookie, you will see your own personalized data served from cache, lightning fast. For every other user, a new connection needs to be made, but again, Redis is fast enough to handle it. So what we're basically doing is creating a bulletproof way of returning your username without having to access your origin server. It's kind of nice. So this is what it adds up to. You get You have your cookie, you get the endpoint, boom. Now what do you do with that? All fine and dandy, what do you do with that? Well, then again, you can go back to your placeholder techniques. You can either load it via AJAX or web components, or you could just render it via ESI and process it as local JavaScript. Or you can use, and that's the final bit of the presentation, you can use Edge Stash. And Edge Stash is also a module that we've built. It's basically Mustache. Who's heard of Mustache before? Mustache templates, like a lot of them. Who's heard of Twig and all that kind of stuff? This is just a Mustache implementation. So basically, at your template layer, as a front-end person, you could just drop this in here, the variable name Edge Stash, and Varnish will just handle it. Like usually when you do this in PHP, in your Twig templating layer, Twig will replace that with whatever variable was injected. But you can leave them unparsed and just send them to the browser, or to Varnish rather, and we'll handle it. Then we can inject whatever was sent by the session endpoint, or whatever we can fetch from Redis, we're going to put in there. So you don't really have to care about that. Here's some code, basic code to explain what happens. This is hard-coded. This is not the ideal way, but I try to keep it simple. So whenever you get something that is not in cache, you're going to go to backend response, and backend response gets whatever came back from the backend. If that turns out to be /session, we know that is JSON data, and we're already going to optimize for it. So we're going to call edge stash index JSON that will deconstruct the JSON and save it in data structures for later use. If we're getting the home page, where that placeholder will be, you'll expect a username placeholder to be there, we're already going to parse the response and deconstruct it as well, like looking for all these placeholders and just assigning them. And then at delivery time, if the URL is the home page and we have an edge stash template that was parsed, we're going to add a JSON URL, which is session. So that session endpoint could just be parsed there. And we assume that that is JSON, and that JSON data can then be processed on the edge. The benefit is that as a designer or as a front-end person, as a developer, you can just emit unparsed handlebars, we'll cache them as a template, and then at delivery time, we'll just inject the state as you want it. That is a really fast and flexible way of dealing with it. If you're still unclear about this, like let's say you emit this in your application, and this is your session endpoint, it will be merged to that. Very easy. But the VCL example I gave you, unfortunately, is not very flexible. Again, no problems. Solution I figured out is that you can leverage these headers that you saw for the negotiation, surrogate capability, surrogate control. It's a free-form key, so you can inject anything you want. So I could say surrogate capability edge stash, and then as an application developer, you can have your framework or just your code respond back with a header saying surrogate control edge stash. And then you could throw these unparsed handlebars in there, and you can leverage a link header with an edge stash relationship and just say, hey, Varnish, this is where you'll find the state. I have an unparsed username variable in my mustache template. This is where you'll find the data. And then as a developer, you get that level of empowerment. You could actually say, okay, we're going to drop in multiple link statements, and we have multiple handlebars, and you don't rely on configuration anymore. As a developer, it's a lot easier. And this is the VCL that is associated with that. Again, advanced VCL, these slides will be online, no worries. But the gist is that we're going to concatenate all the link headers because you can have multiple link headers. We're going to throw them together with a comma separator, and we're going to unleash a really ugly regular expression that is going to match an edge stash relationship and gets whatever is between the tags. So again, whatever is here, we're going to try to fetch that, concatenate that, and throw that in here. If it turns out we get a surrogate control header, that means, with edge stash in it, that means that the backend actually replied with unparsed handlebars. So we have work to do. We need to parse that. And when that happens, we're going to prepare for that. And then at delivery time, if we've parsed it, and we have a collection of JSON URLs, we're just going to issue add JSON URL CSV, which is a comma-separated list of URLs. You just give the URLs, hey, Varnish, here you'll find the state, this is all JSON, get it done. And that is the way, how did they say that in the movie? That's the way the cookie crumbles, the way it works. But implementing this could be rather difficult. So luckily, I've built something for Symfony and Twig. I'm in the process of finalizing it for Laravel and Blade, but this is the way it works. So you just do composer, require, and use that component. The only thing you need to do in your Symfony application is this. I've built these custom Twig extensions. You run the edge stash function. You say what the name of the unparsed handlebar should be and where you can find the data. And boom, it's done. I do all the negotiation behind the scenes. I'm checking surrogate capability headers. I'm issuing surrogate control headers. I can even have a fallback under the form of the second line you see here. This is a custom Twig filter. You pipe your username field to it. And what I do is if it turns out you're not behind a Varnish system, it will just let the value true, and then Twig will handle it. No worries whatsoever. If we do figure out that we're behind an edge stash supported Varnish system, I'm just going to issue this one and find the data there, and the rest is done. And I also added a custom function to check in Twig whether or not you're in there. And you could then leverage the mustache syntax, which is quite interesting. Like, imagine this one. And I know I'm reaching the end. I'm almost at the end for it, no worries. You could do if statements, but at the edge level. You could just send those and say, if the username is set, and you do that by the #. If the username is set, then say, welcome username. If it's not set, welcome guest. This is not processed by PHP. You just emit it. It will just emit unparsed handlebars, and the edge will handle it. This is conditions. What else do you have in programming? Loops. Here you go, a loop. Hash dot, and you find the data in users. And imagine that you have a collection of users in there. It will just happen. An interesting way of thinking. Don't think in terms of PHP implementation. Just think in terms of you have mustache syntax that a lot of people use, both in JavaScript, PHP, and other languages. Why not process it at the edge and make sure that you offload whatever is supposed to happen? One thing I didn't tell you, it's a bit sneaky of me, that not all of this is available. Like most of it, what you've seen is available in open. Edge stash isn't. Edge stash is part of Varnish Enterprise, and I'm not a salesperson. I'm an evangelist. I'm a developer evangelist. I'm not going to try selling you anything. The only thing I could say is, if most people don't have the size to buy an enterprise license, if you want to play around with it, we're available on the cloud. And you could boot up our images. We have 14 days free trial on each of these platforms. You go to the marketplace, you boot up one of these instances, you play around with it for 2 weeks. You don't like it, you throw it away. You like it, and after these 2 weeks, it's just as of 20 cents on the hour. You can play around with it, see if it works. And that's the only thing I have left to say. Thank you for sticking around. Thanks for not running away. Thanks for staying awake. See you next time.